Hello, my name is Felipe Gavilan, and in this video, we're going to talk about statements, functions, namespaces, assemblies, and more. As always, if you want to learn more about C#, check out my Udemy course today, link with a discount in the description of this video. Alright, so I'm going to assume that you already have Visual Studio installed, so let's get started. Alright, so let's create a console application. Let's go to create a new project. We have here console app. If you don't have it here, you can always write console here and then you will get filtered. So here we have console app. I can name it Learning CS of C#. Next, as you can see, we're going to use .NET 7 and we're going to keep this unchecked. So let's click on create. So we have here Visual Studio with our application. Let me delete this code and let's start from the beginning. The first thing that I want to do is to create a variable. A variable allows me to store data in memory so that I can use that data later. For example, I want to say int, which is the data type of my variable. Then I can give a name to my variable. Let's say measure equal to, let's say 30 semicolon. So what do we have here? As we said, here we have the data type of the variable. Data types allows us to indicate the nature of the data. For example, is it going to be a number? Is it going to be text? Is it going to be a date? That is what the data type is all about, indicating what kind of data we're dealing with. Then we have the name of the variable, the identifier of the variable. In this case, it is measure, which means that in this variable, I want to store some sort of measure. With this first part, I have declared my variable. Then after that, I can initialize my variable, which means assigning a value to the variable. For that, I can use the equal sign, and then I can use the value that I want to assign to the variable. In this case, it is 30. And finally, we have a semicolon, which marks the end of this statement. This is a statement. A statement. And by the way, we're going to talk more about this, but this is a comment. So this is an example of a statement. Then something else that I can do is to print this value in the console. For example, I can say console.writeLine. We're going to talk more about this in just a moment. For now, I will just say measure. I want to print into the console the value of the measure variable, and this is another statement. And notice, of course, that it ends with a semicolon. Now I can press Ctrl F5 to run our application, and we can see that in the console we have 30. Excellent. Now, there are a couple of things that I want to talk about. First, we're not limited to having a simple value here. This is a literal. A literal is a piece of data embedded into our application. In this case, this is just the number 30. I can use an expression. If I want to make an operation, for example, I can say 30 times 12. And then the value of measure is going to be the result of multiplying 30 and 12. Let's see that. Let me press Ctrl F5 to run our application. And let's see that now in the console we have 360, which is the result of multiplying 30 and 12. Now, notice something. Notice that I changed the value of my measure variable, and that change was propagated into the rest of the application. By that I mean that I changed the value here, and that change updated what I printed into the console. This is what is great about using variables, and that is that you can reuse their values later. I didn't have to modify this line of code because this line of code is referring to this variable that I am initializing here. Something else that I want to talk about is this line of code. We have here console.writeLine. What is that? Well, console is an example of a class. We remember from the previous video that a class is a unit of data and behavior, data and functionality. So here, as we can see, we have this class console. We have a lot of code here that we probably don't understand yet, but the important thing is that a class is a type that represents a unit of data and functionality. And by saying console, I am accessing that type, and then by using that dot operator that we have here, we are trying to access one of the members of the class. When we talk about members, we talk about that data and functionality that type has. So for example, here we're accessing the writeLine functionality, the writeLine member, which is a functionality that, as its name implies, it allows me to write a line of text into the console. And in order to indicate what text I want to print, I use parentheses to first invoke the functionality and also pass whatever piece of data I want to print into the console. In this case, the measure variable. So that is why we got 360 in the console. Now, who created this console class? I didn't do it. This was created by Microsoft. This comes with C#. This comes with .NET. So this is predefined functionality that we can use. Of course, we can create our own functionality. For example, I can come here and indicate that we want to create our own functionality. So what I will do is that I will indicate the data type that this functionality is going to produce. In this case, it's going to produce an integer. And let me say kilometers to meters. So this is a piece of functionality that by its name, we can deduce that it is going to convert from kilometers to meters. So I'm going to receive as a parameter of this functionality an integer, and the name of that parameter is going to be meters. Alright, and I will put here what is known as a block of code. So what do we have here? Again, we have the data type that this function is going to produce. I gave the function a name, a meaningful name, that indicates that we want to convert from kilometers to meters. And then we indicate that we want to receive information into this function. This is called a parameter. And then in here, I will say int, because I want to declare a variable here, which I will call kilometers. Then I will say meters times 1000, and then I will use a return statement in order to return the kilometers variable. So this function is producing this value that we have here. Now I can, for example, instead of doing this like this, I can say kilometers to meters, and I can pass 5. And so what we're doing is that I am reusing this piece of code that I put here, so that 5 is going to be passed as meters, and meters is going to be equal to 5, and 5 times 1000 is 5000. So we expect the value of this measure to be 5000. So I will name it measure 1 because I want to duplicate these two lines of code. Actually, I want to duplicate these two lines of code. And I want to say here measure 1. And notice that before I made that change, we had a red squiggly line below measure indicating that we have an error. The error is that there is no measure variable here, because now I changed the name to measure 1. So I have to say here measure 1. What I wanted to do was to put here, for example, a 6, and then measure 2 and measure 2. So as you can see, we are reusing this code in these two places, in this place and in this place. Now let me press Ctrl F5 to run our application, and let's see that indeed in the console we have 5000 and 6000. Of course, we can create methods that do not produce a value and also do not receive a value. For example, I can say here void. Notice that we use void to indicate that the function that we're going to create does not produce any kind of data. It does not output any kind of data. I'll put here print my name. Since I don't want to pass any parameters, I can just leave this parenthesis empty, a block of code, and then I can say console writeLine, and then use these double quotes to indicate that I want to pass text, and in here I can put I am Felipe. Then I can come here and say print my name, and notice that I have to use parentheses in order to indicate that I want to invoke the function print my name, Ctrl F5, and we're going to see that we have here I am Felipe. Now as you can see, I can use my own functionality, I can use Microsoft functionality. So a program can get really big. So how do we organize our program? Well, for that, if we go back to console by pressing F12 here, you can see that we have namespace system. A namespace allows us to organize our types. Just like in Windows, we can organize files into folders. You can think of namespaces like folders for our program. So my console application lives in the system namespace. In order to be able to use the console class, I have to use system. I have to import system in order to import the types that are contained in console. But as you can see, there is nothing here that mentions that we are importing system. That is because system is a special namespace that is configured by default to be imported automatically. I can change that if I want to. I can come to the Solution Explorer, which is where the files of my solution are located. As you can remember, we created a console application, which is a project, which is what we are highlighting here. Now, above that, we have a solution. A solution is just a collection of projects. For example, I could have here a console application, a web application, a mobile application, and so on. So in this case, this solution has only one project, which is our console application. If I click on here, this is the project. If I click on the project, we're going to see that we get this file. This is the CSproj file, which allows me to configure my application, my .NET application. Here, as you can see, we have that the target framework is .NET 7. But also we have implicit usings, which means that we are allowing to have implicit imports in my application. This is enabled by default, but I can disable it if I want to. Ctrl S to save. Now if I go back to program, we're going to see that now, after a couple of seconds, we're going to get an error here, as you can see. Now our program can't find the console class because it doesn't know that it is in the system namespace. Now I have two solutions for this. The first one would be to come here and say system.console.writeLine. What I'm doing here is to use the full qualified name of the console class, which allows me to then find it and be able to use it. As you can see here, now we don't have a red squiggly line here, indicating that indeed we can use the console class because we just found it. Now, if I don't want to do that for every single instance of console, what I can do is to import it. I can come up here and say using, I can use the using directive to say system. And this statement that I have here allows me to import all of the types that are in the system namespace, which then allows me to just use it like this. I don't have to write system.console.writeLine, etc. No, I can just use console and I will be able to find the console class. Now, if you notice here, we have this in a opaque color, indicating that this is unnecessary code. And if I press Ctrl dot, I can click on Simplify Member Access, which is going to delete the system dot because it is not necessary since we are now importing the system namespace. So again, we use namespaces to organize the types of our application. This is essential for big applications. Now, I don't want to use this here, so I will just delete it. I prefer to use implicit usings. So let's go back to the learning.cs file. And I will put back here enable, save, and if we come back here, we're going to see that now we don't have any errors anymore. Now we have run our application a few times, but where is our application located? For that we can go to the Solution Explorer, we can right click on our project and click on Open Folder in File Explorer, and we can come to bin of binaries, debug, .NET 7, and in here, as you can see, we have an executable. If I try to run it, we're going to see that nothing happens. What happens was that a console application quickly open and close. But what if I want to actually see the result of that console application? Well, for that I can shift right click here, open PowerShell window here, so that I can open a terminal, and I can say, let me check the name, learning.cs, so L, tap, learning.cs.x, enter, and as you can see, we have the output of our program here. Now, as we mentioned in the previous video, something that we produce is an assembly. This DLL is the assembly. The assembly contains the intermediate language that was compiled from our C# code and also metadata about our application. We're going to see more about that later, but I just wanted you to see that this is the program that our source code is being compiled into. Now, it is important to note that when I run this X file, automatically this code that we have here was executed, right? Well, that is because in .NET, when you run a program, what gets executed is the main function. Now, as you can see here, we don't have a main function. We have a kilometers to meters function. We have a print my name function, but we don't have a main function. That is because we're using what is known as a top-level statement, which basically hides the typical ceremony that we need to have in order to execute a C# application. Let's see that. Let me create a new project. Let's go to the Solution Explorer. Let's right-click on the solution because I want to add a new project. I'll use again a console application. I'll name it main function example, enter, and I will click on do not use top-level statements. Create. And as we can see, we have a program file. Just like before, we have here this program file. We have here also a program file, but this one is different because this one has class program and the main function. This main function is the entry point of my application. Now, in newer versions of C#, we can use top-level statements which allow me to basically hide all of this, and just concentrate on this code that we have here. So as you can see here, we don't have that class program or main function. We only have the code that is going to get executed. Now, it is important to note that we can only have one top-level statement file per application. So we have this program CS file in our project, in our Learning CS project, which is a top-level statement, and we can't have more level statements than that, because this gets compiled into the entry point of my application, and my application cannot have two entry points, of course, so we can only have one top-level statement. There is not much difference between this and this. You can write the same kind of applications whether you use top-level statements or not. So let's go back here and let's talk about a little bit about the syntax of C#. As we have said before, every statement finishes with a semicolon. We can use identifiers for variables and also for functions. Now, it is important to note that by convention, C# variables are named using camel case, which means that the first letter of the first word of a variable is in lowercase. So if I say measure from my home to my work, for example, and let me copy this and put it here, you can see that we have that this variable is composed of several words. So we have measure from my home to my work. So we have that the first letter of the first word is in lowercase, but subsequent first letters of subsequent words are in uppercase. This is camel case. This is different from Pascal case, which is the one that we use here, which says that every word will have its first letter in uppercase. Now, this is just a convention. You can do whatever you want. If you don't want to use that convention, you can just not use it. Your program will still work, but you will be outside of the convention. It is important to note that there are some rules that you have to follow when naming either functions or variables. For example, an identifier cannot start with a number like 5. For example, I can't do this. I can put a number, for example, at the end of the name, at the middle of the name, or in whatever part I want. But an identifier cannot start with a number. It can start with an underscore. There is no problem with this, but it can start with a number. Also, it is important to note that there are reserved keywords that we can't normally use as an identifier, as the name of a variable or a function. For example, I can't say int equal to 5 semicolon, because int is a reserved keyword, because int is the name of the data type int. Now, if I wanted to, I can put an @ sign here, and this allows me to bypass that rule and actually name this variable as int, though this is not recommended. Why is that? Because in my opinion, this is not a meaningful name for a variable. For example, this says measure from my home to my work. So from this you can figure out that what this variable holds is a piece of data that indicates how many meters are there from my home to my work. Okay, that is great. With that I have context I know what my variable is about, but with this, I don't know what this 5 means. What does it mean to have a variable named int? This in general does not make any sense, it is not productive for us, so it is indeed not recommended. Unless you have a very good reason, please don't do it. As we mentioned before, we have literals. Literals are just pieces of data embedded into our program. For example, this is a 5 literal, which is a number. This is a 6 literal, which is another number. 1000, another literal. This is a string literal, which allows me to represent text in my C# application, and so on. And finally, as we mentioned before, we can have comments in our application. Comments are great because they allow us to give some context, some explanation about a piece of code, and also, as I mentioned before, our C# code gets compiled into intermediate language, and this compilation process removes the comments. So, comments are here in development, but when we have our application here, comments get removed. So, they do not make our application bigger or slower or anything like that, because they get removed in the compilation process. So this is it for today. In the next class, we're going to delve more into types, and also we're going to learn how to create our own type. If you want to learn more about C#, buy my Udemy course today. I also have courses on Entity Framework Core, concurrency in C#, among others. Link with a discount to all of my courses in the description of this video. Thank you.